So looking at local linear approximation, sometimes it's kind of helpful to get an idea of really what's going on instead of just memorizing a formula. So if I have some function, say f of x, local linear approximation is going to approximate the value of the function using the equation of the secant line. And this is beneficial around a small interval around x. So if I take some point A, that's going to make it really easy to calculate the function at that point. Then if I find the equation of the secant line between those 2 points, you're going to see I'm going to have a good approximation to the value. If I plug in the secant line, if I plug in that equation around points x, I'm going to have a pretty good approximation, but it only works for a small interval around x. So in college algebra, we recalled the equation of the secant line is y minus y1 equals the slope x minus x1. And we can rewrite this using some calculus terms. The value of the function at some point x, that might be hard to calculate, is going to be found by using this point A. So this would be f of A equals the derivative at A, that's the slope of the secant line, times the difference in x and A. So your book uses this notation and they go one step further and solve for f of x. F of x is approximately f of A plus the derivative of the function at A times x minus A. So let's look at this specific problem. This function is written as the cube root of x. In this case, x is 24. So we need to pick an A value that's close to 24. That's going to be really easy to calculate the cube root of that. So if I just kind of play 2 cubed would be 8, 3 cubed is 27. So 27 is pretty close to 24. So the number I pick for A is going to be 27. But I'm going to write that as 3 cubed because it's going to make my life a little easier when I plug it in the function. So the value of the function at 24 is going to be approximately the value of the function at 3 cubed plus the derivative of the function at 3 cubed times x minus 3 cubed, which x in this case is 24. That's the point we want to calculate. So 24 minus 27. 3 cubed, 27. So what is the value of the function at 3 cubed? That's simply 3, right? Because if I plug in 3 cubed, the cube root of that, plus the derivative at 3 cubed. What is the derivative of the cube root of x? That's going to be 1/3 x the minus 2/3. So I could write that as 1 over 3 the cube root of x squared. So it's 1 over 3 times 3 squared because x, in this case, I'm plugging in 3 cubed. The cube root of 3 cubed is 3. 3 squared would be 9, so I get 1 over 27. That's going to be plugged in right here, 1 over 27, times 24 minus 27. That'd be minus 30. So I would get 3 minus 3 over 27, which would give me 20. Can I plug that in right? 3 minus 3 over 27. 26 over 9, which is approximately 2.88888. I need to round 3 decimal places, so 2.889. So hopefully that walks you through what's going on there. If you have any other questions, please let me know.